Hi, I'm Dr. T. Welcome to my office. In this video, I'd like to talk about some big balls of gas, specifically the outer planets, or the gas giants. So with these planets, we of course got the largest planet in our solar system, Jupiter. It's coming right after the asteroid belt. And I should point out that the distances between planets get larger and larger as you go further and further out. So most models that you see are not even remotely to scale, because if they were, you would either be zoomed in and you wouldn't see the gas giants, or you'd be so far zoomed out that the sun and all of the inner planets would all look kind of like a glob. Now, the gas giants, as their name suggests, typically are made out of lightweight elements like hydrogen, helium, and those individuals. The inner planets typically are rocky. They are heavier metals, or heavier elements like silicon and metals and whatnot. But once again, gas giants, smaller things that typically are gases. Although, if you were to go into Jupiter and you started going to the core, I mean, apart from being dead, you would start finding that, the hydrogen would be, at certain points goes to liquid, and we think even solid metallic hydrogen at the very core of Jupiter. We don't know that for sure, but that's the current hypothesis. Okay, so you've got the gas giants, you've got Jupiter. It's got a whole boatload of moons. Once you start getting out into the outer planets, they typically have moons, and more moons. Jupiter's largest moons are known as the Galilean moons. Those are the ones that Galileo Galilei from earlier in the series could see. So those are your nice big moons. So yeah, you've got yourself Jupiter. Next up, Saturn. It actually gets its name from how long it takes to do its orbit. It is slow Saturn is the idea. Anyways. So Saturn, once again, quite a few moons, and of course, its most iconic feature, the rings, which are basically made up of tiny, small particles. Turns out if you get too close to a gravimetric source, aka you get too close to a big planet, there's what's known as the Roche limit, and it depends on what you are, but the uneven gravitational pull from something that's really big will actually do a couple of things. One, gravitational pulls will do what's known as tide locking, and we can see this with our moon, where something will rotate at the same speed it orbits. So if you're talking a planet, then that would be your day and year would be the same. Now, the other thing that happens if you get even closer is not just tide locking, but you actually get these kind of ripping and shearing forces as you try and orbit, and that will break you apart. And so the rings of Saturn are within the Roche limit, which means they are close enough to a big gravity source that the gravitational pull and the uneven gravitational pull will break them apart. Now, of course, Roche limit depends on, what you're made out of. So, something that's soft and squishy or kind of crumbly is going to have a much larger Roche limit than something, it's a block of iron kind of scenario. Okay, side note, fun fact, Saturn has very low density. It's less than that of water. Go figure. I don't know why everyone likes to quote it, but I'll quote it because everyone else is doing it. Next up, we have Uranus. That is the preferred pronunciation. The other one just leads to way too many jokes. This was not discovered until after the development of the telescope. So this one is far enough away and dim enough. You need a telescope for this one. There were early sightings. I believe it was Galileo actually has notes where he marks that, but he thinks it's a star. So, he marks that it's there. He just doesn't realize it's another planet. So yeah, you've got Uranus. After that, you've got Neptune. Neptune was discovered a little bit later on, and it was realized that Uranus's orbit just didn't really make sense unless there was another planet further out. And that, of course, was Neptune. So that was actually predicted. Its location was predicted before it was found. So it's like, hey, we got to have a planet. It's got to be here. Take a big old telescope, point it there, see what you see. Yep, there it is. And like real quick. Once we worked out where it was going to be, we pointed a telescope and boom, no time flat. Now, with this kind of going out, then we start seeing, well, we don't really start seeing such. We start going, well, maybe there's another planet. And so the thought is, okay, let's start looking up. And this is in the 20th century at this point. So we start looking for another planet, and we find Pluto, which is quite controversially a dwarf planet, because Pluto and its moon Charon, which they almost became a binary planet. The definition for a binary planet never quite passed committee kind of things, but Pluto and its moon Charon. Charon is almost as big as Pluto. It's significantly smaller. Don't get me wrong. It's not like they're twins. But it's big enough that the point that they orbit, so whenever you have two bodies that orbit each other, they don't orbit the center of one of the two bodies. So like the Earth and Moon, the Moon and the Earth orbit around a single point. Now that point is still within the Earth, but it's not the center of the Earth. For Pluto and Charon, that point is outside of Pluto. So they're really, arguably, a binary planet. So there's two planets orbiting a single point in the center of them, in between the two. Although binary planet didn't actually become a thing when dwarf planet came in. So Pluto and Charon, Pluto is a dwarf planet, Charon is a moon, although you could really argue that they are both dwarf planets. Now, the reason they're dwarf planets is you have the Kuiper Belt. And the Kuiper Belt is going to be made up of what we call icy bodies, or what could easily become comets. So these guys are going to be made up of primarily things that we would view as gases or liquids on Earth, but because they are far enough out in the solar system, it's cold enough that these things are no longer gases or liquids, these are solids. These are therefore what we're going to call ice. Not all ice is water ice. So we got water ice, carbon dioxide ice, aka dry ice. You can have ammonia ice, methane ice, oxygen ice. Yeah. Now, the Kuiper Belt objects, Pluto included, all tend to have very elliptical orbits. Ones that are much more extreme. Most of the planets have elliptical orbits, but they're almost circular, not quite, enough that Copernicus was tricked to thinking they were circles. Admittedly, just about everyone were seduced by the circle. But these are definitely not even close. Now, some of them will have an extremely elliptical orbit. And these are ones that the gravitational pull of something has caused it to accelerate one way or another, such that it's got an orbit that's going to be very elliptical. It's going to head very close to the sun. As it starts getting close to the sun, then the ices are going to start sublimating. They're going to start turning into a gas and leaving a trail of dust behind them. This creates a tail, and what in the space has tails? Comets. So these will be comets. Now the tails always point away from the sun. They do not point in the path that they are traveling, but they point in the direction away from the sun because it's material on the comet that's being blown off of the comet by the solar wind. Hey, sun is big star, it's giving off lots of energy, and it's throwing off lots of charged particles, lots of not so charged particles, just shooting that off into space. So we have what is known as a solar wind, which is those particles just coming off the sun constantly. And this is a lot of particles because, once again, the sun is huge. And the solar wind is going to interact with the comets, creating their tail. You only get the tail from a comet when it gets relatively close to the sun. When it's far away from the sun, you don't get a tail. It's just kind of look like a dirty snowball, and that's what our probes going to comets have found. It looks like a dirty snowball because you still typically have some of that rocky stuff going on. You've got other things. It's not just the ice there. Now, Kuiper Belt, it's chock full of dwarf planets. So I'm going to go through a few of the kind of more common ones, or the better known ones. We're finding more of these just every few years. Okay, butchering the pronunciation, Haumea, I think. This one is a weird one. It is around the same distance as Pluto, give or take a lot. But this is kind of in the Pluto-Charon area. Then we got Mechamia, I cannot pronounce these, and Eris. These are going to be dwarf planets kind of well into the Kuiper Belt. There have been several that have been found over in here, and there's like half a dozen kind of still waiting names kind of things, and several others that have been named that I'm just not. I'm butchering these badly enough as is, so I'm just gonna keep keep not doing it. Beyond the Kuiper belt is the Oort cloud. The Oort cloud is less belt-like and more just kind of like surrounding the sun. And this is going to be more materials that are, you know, comet-esque-like materials. So lots of ices. It's downright chilly out there. You know, oxygen is quite often a solid kind of scenario. So yeah, you've got your Oort cloud going back there. And that is, the best of our knowledge, our solar system. Much further out, you're going to get into really into deep space. Once you're no longer really a part of the solar system, the sun's gravity does not have a meaningful impact on you, and you're really just kind of part of the galaxy or part of a local star cluster. There has been talk of maybe there's another planet out there. Some of the orbits kind of look like that. Maybe that's the case. We could be going back to where we were in the 30s with Pluto. That said, you know, that it's way too early to make that call, to say the least. And it's not, and we haven't seen it. So, you know, at a certain point, you got to actually spot the thing before you call it. And we don't really have the math of the different orbits really to even say that it's where it's at, or even that it's there, and we definitely haven't spotted it. So for those documentaries going, there is a 9th planet out there. Yeah, sorry. There may well be, but we definitely haven't found it yet, and it's way too early to call it. So with that said, welcome to your solar system. Have a nice day, and I'll see you in the next video.